Alright, welcome. This is the video key for the Unit 1 take-home test. Just wanted to kind of introduce to y'all how these are going to work. So I've got some highlighted questions. Anything that you see highlighted in green, any question, is one that I'm not going to key. That's a problem that we're leaving blank to let you practice on your own. Anything that's highlighted in blue is something I'm going to do on this video. In case you're skipping ahead, I'll still do that problem. And anything that's written in red ink is something that I've already done. So those problems are there. You can check and give those answers. So it's the I do, we do, you do kind of idea. Alrighty. True, false stuff. The only thing I want to point out here, you can check your answers for true and false. But make sure if it's false, you're correcting the statement to make it true. So I highlighted these three in green so that you're correcting it yourself. I know for Mrs. Holm, at least for my students, I told them they didn't have to rewrite the whole sentence. So if you wear glasses, I just put still need to wear goggles during labs. Okay, so please make sure you're checking those answers. If you ever need to pause or skip ahead or fast forward, feel free if I show the answers too quickly for you. Alright, so this is some stuff I've got. I taught my students in my class to sing the alphabet. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, blah, blah, blah. And for the periodic table. So that you can see M comes before N in the periodic in the alphabets. And when the periodic table was being created, M, atomic mass, was the first periodic table. The current or modern periodic table is by atomic number. So it's easier to help you kind of keep that straight. So again, I've got those answers written in red. You can check your work. But let's look at number 11 together. So number 11 says the least reactive group or family on the periodic table is called the blank, and they have blank electrons. Okay, so the least reactive, those are the people who don't farm their own food, they don't cook their own food, they don't fold their own laundry. That would be the kings and the queens. They don't have to do their own stuff. Or the nobility, okay, noble gases. The noble gases don't react. Especially neon and helium. They don't react at all because they're royal. They don't have to do their own chores. And that's because the noble gases are in family 18 or 8A, which means they already have 8 valence electrons. So their octet is already filled. They've fulfilled the octet rule. So they don't need to react with anyone. Go ahead and check your answers on these ones. Number 13, again, I'm not going to do that one for you, so do that one. Number 14, the problem students were having is just the wording of it. So the elements in group 15 or 5A have blank electrons in their outermost shell. The outermost shell is also called the blank electrons. So that's just valence electrons. So now if we read the question, elements in group 15 or 5A have blank valence electrons. Students are usually really good with saying, well, then it's 5 for 5A. All right. You've got to know your groups, the first two groups and the last two groups on the periodic table. So that are, you need to know the special names of these groups on the periodic table. And remember, you do not get a color-coded periodic table on test day. So make sure you're memorizing those. That'll help with 15. But if we come and look at 16, it says, which compound contains an alkaline earth metal and a halogen? Alkaline earth metals are family 2. Halogens are family 17 or 7A. So I always tell my students to take out the garbage on multiple choice tests. And that means I'm looking for the metal, the first thing, to be from family 2. Be, beryllium is in family 2, so it might be these choices. But sodium is in family 1. Sodium's an alkali metal. So if I'm going to take out the garbage, that's garbage. It's not those answers. Nitrogen is in family 15, right here. And the halogens are family 17. So it's not nitrogen. And now that I've eliminated 3 choices, I can pick B as my correct answer. All right. Go ahead and work on number 18. Number 18 is really similar to number 19. Okay? And that's chemical properties mean they're the same group or family. So if you understand how number 19 works, you should be able to do that one. And same thing with number 20. Because they're all kind of the same there. I got printed goofy, so the answer for number 21 is on the next page. I'll show you that. Okay, for this stuff, go ahead and check the red answers. I'm going to let you have this in green. I want you guys to practice that. Check your color periodic table for help, but you absolutely have to memorize these 4 groups. Okay, so push pause if you still need this. For the scientists and their contributions, okay, or the old dead white guys, we've got a total of 6 scientists you need to know. So I put 3 of them on there. You can check your work. If you still don't know these other 3, you're going to need to look on pages 3 and 4 of your notes packet, but also make sure you're memorizing these guys. So if you need to make flashcards with Dalton on the front and propose the atomic theory on the back, then that's what you need to do. But make sure you're memorizing this and you're studying for the test as well. Okie dokie. Oh darn, I've got something in the way there. Let's see if I can find this now. Okay, you can check your answers for metal and nonmetals properties. Let's look at number 37. So, for number 37, be really careful that you're answering the whole question. What they're asking you is they said, what element in period 2 will be dull and an insulator? So they're giving you 3 parts of this question. Dull and insulators, those are properties right here, dull and insulators of nonmetals. So they're saying what element in period 2 is a non-metal? That's what this question is asking. So we're going to take out the garbage, right? Lithium is in period 2, but it's a metal, so that's garbage. I'm not going to pick that. Nitrogen is in period 2, right, because this is period 1, that's period 2, and it's a non-metal, so that looks good, but I'm going to keep checking. Beryllium's in period 2, but it's a metal, so that's not my answer. And magnesium's super garbage, because it's in period 3, so it's definitely not magnesium. So now that I've taken out the garbage, I can pick B. Which elements in period 3 would be a metalloid? So here's the problem. If we're going to look and find those elements, so I'll see if I can get this to show up on the same page. I think I'm just too zoomed in. Okay, there we go. Now I'm too zoomed in. Let me go back real quick. Sorry, guys. There we go. That's a little bit better. If we find those 4 elements, so boron's right here, Sb is right here, all right, and then we have sodium and, wait, where is it? Yeah, sodium and silicon. Okay, so these 1, 2, 3, 4 elements, okay? All 3 of these are metals because they touch that line. So if you just read this quick and said, which one is a metalloid, you might say, oh, it's boron, because that's a metalloid. But boron is not in period 3, right? So you got to make sure you're answering the whole question. Okay? Sodium is not a metalloid, so that's garbage. But all 3 of these are metalloids. So then I need to say, in period 3, my metalloids would be touching this transition line. That's just silicon. So silicon is a metalloid and in period 3. Do not go too quickly. Make sure you're answering the whole test, or excuse me, the whole question on the test. Right. If we're going to come on over here to page 3, okay, it's the same thing I'm going to tell you here, that you're answering the whole question. So for 41, they're saying which of the following metals in group 14 has a tendency to lose electrons? Let's answer this first question first. Neon and nitrogen are not metals, they're nonmetals. There it is, neon and nitrogen. So that's garbage. I'm going to take out the garbage. Copper, right here, is a metal. And tin, way down here, is a metal. So maybe that's it. So I've answered that part of the question. Group 14 is right here, though. Copper is not in group 14. So it breaks that rule, and look, I took out the garbage. There's my answer. So you're able to answer this question without even looking at this lose electrons distraction. All right, so try that same process for 42. Wonderful. If you are still watching this video and you are not just skipping through, I'm going to give you some extra credit. So if you go ahead and write this and draw me some glasses, okay, it's kind of goofy, but go ahead and draw me some glasses so I know that you are still watching. Okay, you can even put a little smile on your face there. Go ahead and put plus 2 points extra credit. Okay, we'll give you extra credit for doing extra work and watching that video. Thanks, y'all. All right, down here for these ones, I want you to do these 2 together on your own. Nonmetals are most reactive. Remember, halogens. And put some other hints for you in there. All right. Down for the bottom. Let's see what we can find down here. Okay. We're going to do these blue ones together. So bromine has 4 energy levels. Which noble gas has the same number of energy levels? So remember, if you're building the levels of a hotel, you build the first level, and then the second level, and then the third level. You don't build these 3 levels, and these 3 levels, and these 3 levels. So energy levels are from periods on the periodic table, which means bromine right here in period 1, 2, 3, 4. They're asking me for the noble gas, which is this family, in period 4, which, whoop, Krypton, right there. So we can go ahead and pick krypton. Neon is also a noble gas, okay? But neon has 2 energy levels because it's in period 2, so that's not our answer. Potassium and chlorine aren't noble gases, so that's not our answer. Okay, list 2 other metals. So they're asking me for 2 metals, if I'm reading the questions right, that have the same number of energy levels as aluminum. So that means same period as aluminum. So here's aluminum right here. My only possible choices are the things in the same row or the same period. And the only metals are these ones. Okay, all of these right here in period 2 are nonmetals. So those would be my 2 answers, sodium and magnesium. Those are the other 2 metals in period 3, sodium and magnesium. And then, oh my goodness, your 8th grade teacher would have a fit. I'm seeing so many people miss this. Electrons are earrings. They're outside the atom. The nucleus, especially if you look down here at the Bohr model, has got protons and neutrons in it. I cannot tell you how many people have been writing protons and electrons. The nucleus has protons and neutrons. Right? Because electrons are like earrings. They're outside and they're little. And that means the charge. It's made up of positive things, because protons are positive, and neutral things. So positive charge plus no charge is positive. Okay? It's a dense, positively charged nucleus. All right. I'm going to let y'all work on number 57, but we'll do it the same way as 58. And that is, you are your protons. Your identity is solely based on protons. So 8 protons means number 8 on the periodic table, oxygen. I always tell my home students, what do you call oxygen with 9 protons? And that's a trick question, because that's fluorine. It's not oxygen anymore. So go ahead and write what element is represented. It's oxygen. Okay, and it asks you for the mass, right? So electrons are like earrings. They don't count on the scale. They're too light. But the mass is protons plus neutrons. So 8 protons plus 8 neutrons would be 16. You are not going to say 15.999. Okay, don't say that. That's the average mass of oxygen. But we're saying what's the mass of this atom. Okay. How did I know? Because 8 protons plus 8 neutrons equals 16. Total electrons, you can count up the dots here, or you can remember 8th man, that atomic number equals protons equals electrons. So if there's 8 protons, there's 8 total electrons. And just the valence electrons are the outside ones. So I'm just going to count the dots on the outside. That's 1, 2, 3, 4, 5, 6. 6 valence electrons. Otherwise, we could have gone to the periodic table. Oxygen's in group 16 or 6A, so it's got 6 valence electrons. That's how else we could have known. All right, we're cruising. We're getting there, guys. Okay, go ahead and take a look at these ones. I've got some answers for you already, but we're going to draw the Lewis dot structure for potassium. Lewis dot structure is also known as electron dot structure or electron dot formula or dot formula. But potassium on the periodic table is K. So K is what we're looking for, and all we want is the valence electrons. So if I find potassium, it's an alkali metal. It's in family 1A, so it just has 1 valence electron. And I'm going to put it right there. It doesn't matter where the first 2 electrons go as long as they're together. So you could have put it on the top. That's fine. But that's okay. Just right there. Looking at these ones, I'm going to have you do 62 on your own. Here's how you can do it. Make sure you're answering the how you know. And then 64 if we look at that together. Okay, 64 says, which group or family is represented by this dot structure? All we care about are the valence electrons. So that's 1, 2, 3, 4 valence electrons. Means it's group 4A. So I'm going to say it's group 4A. How did I know? Because there's 4 valence electrons. Okay, you could have said because there's 4 dots. That's great. Looking down at the second half of this page. Okay, you can check your answers there. Number 67, how many neutrons are found in potassium-40? So potassium-40 is an isotope. So when this specific element of potassium gets on the scale says 40. All right? And in order to be potassium, potassium has to have 19 protons. Because 40 protons is zirconium. So this one has 19 protons. So if we're going to look at this, potassium has protons are 19. Electrons don't count in this mass. So whatever this weight is, the 40, 19 of those are protons, which means 40 minus the 19. Okay, so the mass minus the atomic number equals the neutrons, which would be 21. Ape man, remember that's an 8th grade refresher. Hopefully we're pretty good on those, as long as you remember that that's the mass. And then down here, go ahead and take a look at what I did on 68, so you know how to do 69 on your own. Glorious. Okay. For this one, holmium's my favorite element, because, you know, missile, whatever. So if you are still watching, you get 2 more points extra credit if you write holmium rocks. If you don't think holmium rocks, write it anyways. Holmium rocks. Alright, there we go. 2 more points extra credit there. If we're looking at this then, remember this isotopic notation. The big number is the mass, the littler number is the atomic number. So it's total protons and then total protons plus neutrons. So calcium, let's take out the garbage first. This one makes me crazy. And I apologize, it got reformatted by a different teacher, that's why the electrons should be there. But if we're going to take out the garbage, calcium, in order to be calcium, has to have 20 protons. Okay? So if I'm looking at protons, it could be this one, it could be this one, but 41 protons, that's niobium. That's not even potassium, so there's no way calcium could ever have 41 protons. And 21 protons is right here, this scandium. That's not potassium, so it can't be this. So just by taking out the garbage, we're down to 2 questions. We always know that A equals P equals E, so my protons should be equal to my electrons. And here it's not, so that's not my answer. There it is. Okay. 41 minus 20 equals 21 neutrons. So that's how we found it. Please do 72 that same way on your own. Okay. Then average atomic mass of carbon is 12.011. Which isotope is in the greatest abundancy? Okay. That means which isotope is the most common. That also means which one's going to be the highest percent. So you just round to this number. If the average is basically 12, that must be because almost all carbon on Earth is carbon-12. That's why the average is 12. So when you're looking for that scary, weird word, greatest abundancy, we're just rounding it. Okay? Wonderful. Okay, for this, you get 0 points if you have this as your answer. You get credit if you have work shown and this as your answer. So you can check your answer here, but remember, you're not getting credit unless you show your work and calculate it out. Let's look at this one. I did part of this one for you already, where for average atomic mass, there's 3 steps. If you don't remember them, look at page 10 in your notes packet, or you can look at the video tutorial for pages 7 and 8 in the homework packet. But the first step is to make this a decimal number. So I bubbled it over twice, so 0.78, 0.10, and then it's not percent anymore. Okay, that's step 1. Step 2 is to multiply it by the mass. So 78% was 24. That's why I put that there. So if I'm going to calculate that out, so I need to get 3 separate answers. So 0.78 times 24 is 18.72. That is not my answer. That's only a third of it. So keep going. 0.10 times 25. Okay, 2.5. 0.12 times 26. All right, 3.12. Now the last step is to add these 3 numbers up for my total. But if you're going to think about it, we're averaging these numbers. So my final answer should be between 24 and 26. If my final answer is 37, I did it wrong. If my final answer is 20, I did it wrong. It needs to be somewhere in there. But it should also be closest to whatever is the highest percentage. So my answer is probably going to be pretty close to 24 if I did it right. So we're going to go, 18.72 plus 2.5 plus 3.12 equals, there we go, 0.34 AMU, because that's the units for atomic mass. Just like I was hoping. So you are going to do Number 74 that same way. You're going to do 76 that same way, except you're doing these numbers. So it's the same problem, just as a word problem. You need to show work and have your answer. No work, no credit in chemistry. Last page. We are so close, you guys. We got this. All right, back here on the very last page, if we're going to take a look at it, I'm going to give you some extra credit if you draw this with me. Okay, so go ahead and draw us a little pizza. So if we order a pizza, and you're not being very nice, and you go ahead and you eat 70% of that pizza, and I get to eat the rest. Okay, that means I get to eat the other 30%. Right? So even though I didn't tell you, I just said I get the rest, you know that it has to add up to 100. So if you went ahead and drew that, go ahead and put your last extra credit points. You get 2 points for having that there. Because that's how we're going to do number 77. Number 77, they said we have an element. And of that element, okay, 45% have a mass of 43 AMU. The rest, which means all of this, has a mass of 45. So what's the rest then? Okay, of 100%, 45 is this. That means the rest must be the other 55%. So 45% has a mass of 43 AMU, and the rest, which is 55%, has a mass of, and it says right here, 45 AMU. So my answer should be between 43 and 45. It's going to be pretty close to the middle, right? Because it's almost 50-50, but just a little bit closer to 45. So make sure you're showing me the work here, giving me your answer, and then bubble it in this way as well. Okay, last one we're going to do together. This one, molar mass is, for all intents and purposes right now, the same thing as average atomic mass. So for nickel, the molar mass of nickel is the same thing as the average atomic mass. So that would be 58.693. Go ahead and do the rest of these then. Great job. Remember down here, we did this together in class, so you shouldn't have anything else to add. If your teacher didn't get to it with your class period, just go ahead, don't worry about it. They'll remember. Thanks, y'all. Good job, and good luck for your test.